Welcome back, chemistry fans. We've got unit 7, topic 2 up on that. And so we are going to talk about polarity now. So let's get into the content. I believe I have it shared already. Let's see here. And we're just going to move up the slides a few back here. Okay, so what the overall goal of this unit is to talk about this very term that we're going to discuss right now, something called polarity. Well, polarity just means that the electrons are not being shared equally. You have heard of the term polarity maybe in terms of something that is polar, such as the North Pole and South Pole. So they have opposite ends of the Earth. There is bipolar people who have difficulty regulating their emotions. And so they have a chemical imbalance in their brain. And so they go from manic and depressive and they flip back and forth. And those are polarities, if you will. So in a molecule, what we have started to understand is that electrons do not share equally. We call that electronegativity. And if we then want to represent that on the molecule, we can put these dipoles that you see on this image right now. And so a negative dipole, that little d with the negative mark, means that the electrons are more centered on the oxygen than they are on either of the hydrogens. Well, when we were talking about electronegativity in the last topic, we were mostly focused on the bonds and how they don't share the electrons equally in the bonds. Well, now we're going to pull back a little bit and we're going to talk about, well, what happens if we have more than just 2 atoms and we have multiple atoms? How are we going to deal with the polarity across that scenario? So here's what you have to understand is that polarity is an unequal sharing of the electrons. It is going to be because of 2 things. So we've already talked about electronegativity, and that's different. That's the polarity that's in the bonds. This is the polarity of the molecule entirety based on either size or shape. And so if you're looking at this, I'm going to have a better image on the next one. We can start to see, though, there's some similarities in this first row up here. Both of these have 2 atoms. Why would one be polar and the other would not polar? You might point towards the number of bonds. And that does have something to do with it, but more what I want you to focus on is notice the disparity between the sizes. The chlorine appears to be bigger than the hydrogen. Down at the bottom, I want you to look then at the bottom 4 and notice that the difference between these molecules, they both have 3 atoms, but why is one polar and one nonpolar? It has to do with their symmetry. If I cut this molecule in half right down the middle, and I cut this one down in half, the top looks the same as the bottom half on the right, the nonpolar, but the polar, it has more of the electrons centered down here on the bottom half of the molecule. And the same is true for 4 atoms. And if we were to draw a trigonal planar, we would see a similar idea that it doesn't matter how we cut the molecule, we would always have an equal share of electrons, unless you have this scenario where there appears to be more electrons on the bottom half. So let's formalize this and tell you that the only 2 molecules that are guaranteed to be polar every single time are the trigonal pyramid and the bent. I don't like the use of the angular. That's not the more common term. It's acceptable, but we usually just go with the word bent. Okay. There we go. Trying to get this thing. There we go. There it goes. Okay. So the reason you should start noticing why they are polar is because they have extra electrons. It is nice for us to notice that the trigonal planar has a double bond. It is nice for us to know that the linear has double bonds. It is not necessarily the case with 2-atom linear or with the tetrahedral. They just happen to be symmetrical as they're going along. Didn't matter how you cut them, they're going to be symmetrical. It's these unshared electrons is what is making it polar, because there is repulsion that we have talked about between these unshared electrons and the bonds of the molecule. They are pushing on them, they are repelling them away, causing the molecule to bend and causing it to have some unequal sharing of the electrons with respect to the shape of the molecule. Now, polarity can also develop based on size. If you notice there is a small hydrogen and a larger fluorine atom bonded together, the dipole is pointing over here towards the fluorine. The dipole moments are being shown here with the negative and positive. Now, why is this the case? It literally takes longer for an electron to go around a fluorine because it's larger than it would for an electron to go around the hydrogen because it is smaller. Because it stays longer on this larger atom, there develops a more negative charge on one side. Now, it's not that there is an absence. It's more like there is an absence of electrons. It's not that it develops a positive, it's that it just doesn't have the negative charge. So one side holds the electrons longer than the other side. So size is what is important. This is not a new trend for us. We already know that the largest element on the periodic table is francium. One of the smallest up here is fluorine or helium or hydrogen. The hydrogen's in the wrong location. So I want you to notice that the trend overall is that as you move down and to the left, you will increase in size. So the bigger the difference in size, the more polarity we are going to have. So here is our summary for this topic. The polar molecules are linear, trigonal pyramid. The nonpolars are trigonal planar, tetrahedral, and then we should have over here a difference in size also. So polarity also can develop whenever we have a difference in sizes. Okay, so everything about this is what we need to understand as far as polarity is concerned. We need to understand that size matters. The bigger the difference, the more polarity. Shape matters. We have trigonal pyramid and we have bent. Trigonal pyramid and we have bent. And so because of those trigonal pyramid, because of those bent, we can see that we now have a unequal sharing of the electrons. All right. Well, thank you very much for your time. I will talk with you again soon. Bye-bye.